Good morning, dear students. Hope you are doing well. Today I'm going to continue chapter 19, Acids, Bases, and Salts. The objectives that you are going to understand at the end of the session are: describe how the concentration of H plus and the concentration of OH minus are related in an aqueous solution. Classify a solution as neutral, acidic, or basic by using pH. Let's begin with the first objective by explaining the hydrogen ions and acidity. Recall that water molecules are highly polar and are in constant motion. As you know, the collisions between the molecules are in proper and oriented way, and with enough activated energy will produce a product. So a reaction occurs between water molecules as illustrated in this equation. Two water molecules in a reversible reaction will give hydronium ion and hydroxide ion. How they will produce these two ions? A water molecule that gains a proton becomes H3O+, which is hydronium ion. A water molecule that loses a proton becomes OH-. So this reaction in which water molecules produce ions is called self-ionization. Now in pure water and at 25 degrees, the concentration of H plus equal to 1 times 10 to power minus 7 molar, and the concentration of OH minus equal to 1 times 10 to power minus 7 molar. So the concentration of H plus and OH minus equal 1 times 10 to power minus 7 molar. What can we conclude here? That any aqueous solution in which the concentration of the H plus equal the concentration of the OH minus, the solution is neutral. Now, what do we mean by ion product constant for water? Since the ionization of water is a reversible reaction, here the water in two directions gives H plus plus OH minus. The expression of equilibrium constant for water, which we can call it Kw, equal to the concentration of H3O plus times the concentration of the OH minus. So in pure water, the Kw equal to the concentration 1 times 10 to power minus 7 of the hydronium ion times the OH, the concentration of OH minus, which is equal to the H plus 1 times 10 to power minus 7. So the Kw has a value of 1 times 10 to power minus 14 at 25 degrees Celsius. Now let's explain acidic solutions. Let us recall Arrhenius' theory. When the hydrogen chloride gas dissolves in water, it forms H plus in solution. Let's see here the equation. HCl gas gives H plus aqueous plus Cl minus aqueous. Here we want to compare the concentration of H plus with the OH minus. Here the H plus is greater than the concentration of OH minus, where the OH minus comes from self-ionization of water. So what do we call this solution? It is an acidic solution. Now let's take the basic solution. Also here, let's recall Arrhenius base. When sodium hydroxide dissolves in water, it forms OH minus in the solution, as we see here in the equation and in the figure, where the NaOH gives Na plus OH minus. Let us compare the two concentrations. Which one is greater? In water, the OH minus is greater than the H plus. Now what's the source of the H plus? H plus comes from self-ionization of water, so it is a basic solution, or we can name it alkaline solution. Let us classify each solution as acidic, basic, or neutral. If we take part A, where it is given the concentration of the H plus equal 1 times 10 to power minus 2 molar, how to solve it? We have to find the concentration of OH minus and compare them. How to calculate the concentration of OH minus? From the equilibrium constant for water, or ion product for water. So it is equal to the concentration of OH minus equal to Kw over the concentration of H plus. We substitute the values for each one, and we get 1 times 10 to power minus 12 molar for the concentration of OH minus. So compare these two ions. The concentration of H plus is greater than the concentration of OH minus. As a result, it is acidic solution. So the other answers similarly for part B and part C. For part B, it is basic solution because the concentration of OH minus here is greater than the concentration of H plus, and in part C, the concentration of OH minus equal to concentration of H plus. That's why we say that it is a neutral solution. Now, as a conclusion, the concentration of the H plus increases here. We observe that the concentration of OH minus decreases, keeping Kw constant. Now we want to begin with the second objective. A more widely used system for expressing the concentration of the H plus is the pH scale, proposed in 1909 by the Danish scientist Sørensen. How did Sørensen relate the concentration of the H plus and the pH? Here, the hydrogen ion and pH, the pH of a solution is the negative logarithm of the hydrogen ion concentration. So the pH equal minus log the concentration of H plus. Now let's take these two statements. In pure water or a neutral solution, the first statement, the pH of a solution is 7. The second statement, the concentration of H plus is equal to 1 times 10 to power minus 7 molar. Both statements express exactly the same information about the hydrogen ion concentration of a solution, but the first statement expresses the information in a more concise manner. So here we notice in this figure the pH paper that distinguish the solution or that classify a solution as a neutral, acidic or basic by changing its color. Or we can use the pH scale that ranges from 0 to 17. Here, if the pH less than 7, the solution is acidic. We classify it as acidic. If the pH equals 7, it is the solution is a neutral. If the pH greater than 7, so the solution is alkaline or basic solution. How to apply the pH concept? pH equal, as we said, equal minus log concentration of H plus. How to calculate it? The log here is logarithm of base 10. Now log 1 minus log 1 times 10 to power minus 7, as if we are saying minus log A times B. Now log minus log A times B is equal to minus log A plus log B, and we put the minus before the bracket. Here let's apply it on numbers. We have minus log 1 minus into log 1 plus log 10 to power minus 7, so it is equal to minus 0 because log 1 is 0 and log 10 to power minus 7 is minus 7 log 10, where log 10 equal 1. So the answer will be 7. Note here that if the concentration of H plus is greater than 1 times 10 to power minus 7, the pH is less than 7 and the solution is acidic. If the concentration of H plus less than 1 times 10 to power minus 7 molar, implies the pH is greater than 7 and the solution is basic. As a conclusion, pH and the concentration of H plus are inversely proportional. Now, how to calculate pH from the concentration of H plus? There is a formula here. The concentration of H plus equal 1 times 10 to power minus n implies the pH equal n, absolute value of exponent n. Let's take example 1. If the concentration of H plus is equal to 1 times 10 to power minus 3 implies the pH directly is equal to 3. Note, if the coefficient is 1.0, the pH of the solution equals to the exponent with the sign changed from minus to plus. Now, in example 2, the concentration of H plus equal 4.2 times 10 to power minus 10. Here, the value of the concentration of H plus is not a whole number. So we have here decimal, or it is not equal, the coefficient is a number other than 1. The pH will be 9.39. How? Let's see here. You will need here to use a calculator with a log function key to calculate pH. or we can estimate the value to be between 9 and 10. That's why the pH is 9.38. Now, how to calculate the concentration of H plus from the pH? Here the formula is concentration of H plus equal 10 to power minus pH. Let's take example 1. If the pH equal 2, this 2 is an integer, the concentration of the H plus is directly equal to 1 times 10 to power minus 2 molar. This is directly and it is easy without using a calculator. Now in example 2, the pH is equal 10.50, which is not a whole number. What can we do here? If as you know, in SAT exam, you are not allowed to use calculators. So in this case, you try to estimate the value of the concentration of H plus. The concentration of H plus will be between, it will be greater than 10, it will be greater than 1 times 10 to power minus 11 and less than 1 times 10 to power minus 10. Here you can estimate the value, but if you use a calculator, you can get exactly the concentration of the H plus, which is 3.2 times 10 to power minus 11. The last one is how to calculate the pH from the concentration of OH minus. Here we have to use two steps. The first step is to calculate the concentration of H plus from the Kw, which is the ion product of water, and the concentration of OH minus. Then the second step is to calculate pH. Let's take an example here. If given the concentration of OH minus equal 1 times 10 to power minus 4 molar, the concentration of H plus is equal to Kw over the concentration of OH minus. We substitute the values for the Kw and the concentration of OH minus, and we get the concentration of H plus equal 10 to power minus 10 molar, implies the pH is equal 10. Finally, I hope all of you found interest in this topic. Thank you.